Welcome to Subnetting Tips and Examples. First thing we're going to have a look at is the numbers that you can have in a subnet mask. Now, unlike an IP address where you can have any number between 0 and 255, there are only 9 numbers you could possibly have in a subnet mask, and that's because you have all ones followed by all zeros. So within your 8 bits or within your octet, there are only 9 possible numbers, and I'm just going to list them very quickly. Right? It's either all ones, which is 255, right? 10, right? Or 7 ones, 254, right? And as we go down and remove our network bits and add host bits, you can see that we have 252, 248, 240, 224, 192, 128, and obviously 0. Okay, so these are the only numbers you will see in a subnet mask. If you see any other number in a subnet mask, there's an error there somewhere. Okay, so that's the first thing to remember. So subnetting is really not that hard. You're only going to have 9 numbers in there. Moving on, right? When you are calculating number of hosts in subnet, if you remember from the other videos, the first thing we do is we figure out how many ones we need, right? Or how many bits we need in our subnet mask, depending on whether it's hosts or networks, right? So if you can have a look at this example, right? I've got 4 ones, right? Which gives me 15. How do I get my 15? 8 plus 4 plus 2 plus 1, right? You'll notice there that's just 1 less than 16, which is 2 to the power of 4. So anytime you have or you're using your number of ones to calculate, you don't actually have to add up 4 plus 2 plus 1 in this example. I know it's 1 less than 8 or 1 less than 2 to the power of 3, 1 less than the next bit up. Okay, so just as you're calculating, this makes it a little easier for you. There you have 31. I don't even have to calculate it. I don't have to go 16 plus 8 plus 4 plus 2 plus 1. I know it's 1 less than 32 or 2 to the power of 5 because that is the next bit. Okay, so that's very easy. Now we're going to move on to some examples, right? On the next slide, right, we're going to calculate the subnet mask, subnet ranges, show CIDR notation for each subnet, right, for a network 192.168.25.0, right? And we're going to calculate this for 6 networks, 15 networks, 15 hosts per subnet, and 30 hosts per subnet. Okay, so what I'd like you to do is just pause the video here, have a look at these examples, try and work them out on your own, right? Remember, all you're doing is you're working out how many bits to get to the number of networks or number of hosts. Depending on whether it's networks or hosts, you'll add the ones on the left-hand side or the zeros on the right-hand side. Remember, if you're calculating hosts, however many bits you have become 0, and whatever's left become 1, and those are your network bits. If you're calculating networks, then obviously those ones go on the left, right, and whatever's left become host bits or 0. Okay, so give that a bash and we'll have a look at the next slide. Have a look at the first example, 6 networks. Now, just to refresh you on that question, we're calculating 3 things. We're calculating the subnet mask, the subnet ranges, and we're going to show CIDR notation. Okay, it's a class C, which means the only affected octet is the last octet. All right, so for 6 networks, first thing I do, figure out how many bits I need to get to 6. And as you can see there, I have 3 bits. Now you'll see in brackets there that I've got 1 to 6 highlighted, right? And the reason for that is if you are or have legacy equipment on your network, or if you're working on a legacy network, there may be some older equipment that can't use the first and the last subnet, right? That's not a problem for modern networks, right? So we're not going to worry about that, but I'm just highlighting it just so you're aware of it. So for our 6 networks, we need 3 bits. Those 3 bits give us 0 to 7, right? So 8 possible networks. All right. Easy enough. Remember, those are network bits, so they go onto the left. And whatever's left become host bits or 0. So you end up with 1, 1, 1. Those are your 3 network bits that we calculated, right? Followed by 5 zeros. Add those up and you will get 224. 128 plus 64 is 192, plus 32 is 224. So your subnet mask becomes 255.255.255.224. Working out the ranges from here is pretty straightforward, right? All you have to do is, again, look at the value of the last network bit. The last network bit in this case is 32. So starting at 0, to get the start of each range, all you do is add 32. So I'm starting with 192.168.25.0. The next subnet will start at 192.168.25.32. How do I know that? I'm adding the value of the last network bit to 0, my starting point, right? From there, if I want the start of the next subnet, I add 32 to that, which gives me 64. That will be the start of the next subnet, right? From there, I add 32 again, which gives me 96, which is the start of the next subnet. And then as you keep adding 32, 128, 160, 192, and 224, right? Those are the starts of each subnet. And if I look at each one of those starts, obviously the previous subnet will end one before the start of the next subnet. And that's how I have my ranges, or that's how I got my ranges. 192.168.25.0 to 192.168.25.31 as the first subnet, then 32 to 63, 64 to 95, 96 to 127, etc. until you get to 255. CIDR notation, pretty straightforward. 192.168.25.0/27. How do I get my 27? 27 ones in the subnet mask. 8 in each of the first 3 octets, so that's 8, 16, 24. And then 3 network bits, or 3 ones in the last octet. So 24 plus 3 gives you your 27. And that's how you end up with 192.168.25.0/27. Okay, so if you were struggling with this and you didn't quite get to do the examples, I'd like you to give that a try now. So pause the video, try and do the next example. All right, let's do the next example, which is 15 networks. So here we want 15 networks. What we need to get to 15, or the number of bits we need to get to 15, are 4 bits. Right? Again, I've just highlighted there in the corner in brackets, right, that if you are using a legacy network, right, if you're on a legacy network or you have legacy routing equipment, right, you can't use the first and the last network. We're going to assume that we're running modern equipment again. So in this case, we don't have a problem. 4 bits, 0 to 15, that gives us our 15 networks. It actually gives us 16, remember, because you're starting at 0. So those are our network bits, because we're calculating 15 networks. That means they go onto the left-hand side. 1, 2, 3, 4 ones, followed by 4 zeros. This gives us a subnet mask of 240. Right? How do I get that? 128 plus 64 is 192. Plus 32 is 224, plus 16 is 240. So our subnet mask becomes 255.255.255.240. Now, if you remember from the last time, if we're working out subnet ranges, right, you use the value of the last network bit, which in this case is 16. And because there are quite a few subnets here, I'm not going to go through each one. I'm just going to list the first few, and you should get the idea from there. So if we have a look at the subnet ranges, starting at 0 and increasing by 16. Okay, so the start of the first subnet will be 192.168.25.0. Obviously, always starting at 0, right? And we go up to 15. How do I know I go up to 15? Because the start of the next subnet is 16, right? So 0 plus 16 is 16. That gives you the start of the next subnet. The start of the next subnet from there is an addition of 16 again, right, which gives you 32, which means the next subnet goes up to 31. So 16 to 31. Right, then I add 16 again. So I add 16 to 32 to get the start of the next range, and that gives me 48, which means that range from 32 ends at 47. Right, next one is 48 to 63, etc., until you get to 255. Right, obviously, I didn't have space to show all of those, but it's relatively straightforward. In terms of CIDR notation, 192.168.25.0/28. Again, how do you get that? The number of ones in your subnet mask. So the first 3 octets are 255, which means 8 ones, 8, 16, 24, followed by 4 ones in the last octet, which gives me a total of 28. 24 plus 4 gives me 28. Okay, so reasonably straightforward. The next example goes through the number of hosts. And again, just before you do that example, if you haven't done it already, right, remember, if you're calculating number of hosts, when you work out the number of bits you need, those bits have to become 0, and whatever's left becomes 1. So you don't move the bits, you just convert them to 0, right? And the top order bits that remain become 1 to give you your subnet mask. So give that a try. There's a little bit of a trick to the next question, so we'll have a look at that, but try it on your own and let's go from there. Okay, so the next question, C, was 15 hosts per subnet. Exactly the same example, but here we want 15 hosts per subnet. And the first thing you've got to do, as before, you've got to work out the number of bits you need to get to 15. And if you just look at that, the first thing you'll probably do is come up with 4 bits that are needed to get to 15, just like we did in the last example, right? But there's a small problem here, right? Remember in some of our other videos, we discussed the first and the last address in any subnet or network. The first address is the network identifier, which means it is reserved as the network identifier. It cannot be assigned to any host. The last address is the broadcast address for that subnet. All right, now because of that, and because you can't use those 2 addresses, I don't actually have 0 to 15. All right, what I have instead is 1 to 14. I can't use 0, I can't use 15. So I actually only have 1 to 14, which only gives me 14 hosts per subnet. That does not accommodate my need for 15 hosts. Right? Because I don't have enough host addresses, I have to use 1 more bit, which gives me 0 to 31. How am I getting 0 to 31? Right, remember 16 plus 8 plus 4 plus 2 plus 1 will give you 31. Again, I can't use the first and the last address. So I can't use 0 because it's the network identifier. I can't use 31 because that's the broadcast address for the subnet, which means I'm left with 1 to 30. And that does accommodate my need for 15 hosts per subnet. You have to remember now that we are working with hosts. So because these 5 bits that we're using are for the hosts, remember host bits are 0, right? So the host bits are 0. Whatever's left, the 3 bits at the top end become 1s or network bits, right? So you end up with 3 1s, 5 0s, right? And that gives you a subnet mask of 224. So how do I get that? 128 plus 64 is 192, plus 32 is 224. So my subnet mask is 255.255.255.224. Now, if you remember from the first example, this is the exact same subnet mask. Because it's the same subnet mask, we actually end up with exactly the same IP ranges, and we end up with exactly the same CIDR notation. Okay, how do we get our subnet ranges again? Remember, you're starting at 192.168.25.0, and you are adding the value of the last network bit, which in this case is 32. Right, so my first address range starts at 192.168.25.0. The start of the next range at 32, right? 192.168.25.32. The start of the next range is adding 32 to that again, which means 192.168.25.64. Add 32 to that for the start of the next range, 192.168.25.96. Okay, so your subnet ranges become 0 to 31, 32 to 63, 64 to 95, 96 to 127, 128 to 159, 160 to 191, 192 to 223, and 224 to 255. Okay, CIDR notation, simple, number of ones in the subnet mask, 27. Okay, that's that simple. Please don't forget, if you're calculating a subnet mask for number of hosts per subnet, you cannot use the first and the last address. Some of the questions you get in routing and switching exams might ask you to list the valid addresses in a subnet range. All right, now, if you are asked to list the valid addresses in a subnet range, remember, you can't use the first and last. So my first network that I've got here is 192.168.25.0 to 192.168.25.31. But if I was asked to list the valid range, it would be from 1 to 30, right? Because I can't use 0 and I can't use 31. If the range was 64 to 95, the valid IP addresses would be 65 to 94. One above the start of the range to one below the end of the range, right? Remember that first address is the network identifier and the last address is the broadcast address for that subnet. Okay, let's move on and have a look at the next question or next example, D. Again, if you want to just try and work that out again on your own, just pause the video and then we'll move on. Example was 30 hosts per subnet, and surprise, surprise, the answer is exactly the same as the last one. Why? Because again, I need 5 ones to get me to 30. Remember, 5 ones gives me 0 to 31, just like the last example, right? I can't use 0 and 31, so I've got 1 to 30, which accommodates my need for 30 hosts. Right? And everything else is exactly the same. Remember, those 5 ones are host bits. Host bits are 0, so those become 5 zeros. And the 3 bits that are left become 1s. Right? Add that up, you get 224. Right? Subnet range is exactly the same. Right? And the CIDR notation is exactly the same as well, /27. Okay. So straightforward, shouldn't have any problems with that. I've got one more example for you, and it's a bit of a doozy, right? This tends to come up if you do some subnetting exams. You might get a question like this, right? Some advanced routing and switching exam from Cisco or from some other vendor, right? This is the kind of question you can get. All right, so let's just have a look at this question quickly. You have a network, 192.168.10.0. You have a requirement that there should be one network with 60 hosts, 2 networks with 30 hosts, and 2 networks with 6 hosts. All right, which of the following networks are valid in this scenario? Now, essentially what you have to do here is variable length subnetting. So you have to use VLSM, or variable length subnet masks. Right? You can see there's quite a few options I gave you there, right, from A all the way through to J, right? And this is the kind of question you can get in an advanced subnetting exam, or an advanced routing and switching exam, right? In this case, you've got to select 5 answers because there are 5 networks that we're creating. One with 60 hosts, right? 2 networks with 30 hosts, and 2 networks with 6 hosts, right? If you apply the methods that I gave you in the VLSM advanced subnetting video, you should be able to calculate this on your own. I'll give you the answers, pause the video, right? Try and do the calculation on your own, right? And let's see what you come up with. All right, let's see how you did. Your first option was 192.168.10.0/27. Now, this is a Class C address, so first 3 octets default subnet mask should be 255.255.255, right? That's 24 bits, which means if I need to get to 27, I need 3 more bits, right? That would end at 32, and that would accommodate 30 hosts, all right? But I can't use that option because if you had a look at the option list that I gave you, there was no other option for /26, which I would need for my 60 hosts, right? If I have /26, it means in the last octet, I only have 2 bits, 24 bits in the first 3 octets, and then 2 bits to get to 26, right? That means my last network bit is 64, right? Which gives me 60 hosts per subnet. Now, there was only one option with /26, and that was B. So B has to be our first selection as an answer, right? Your subnet range for that particular network would be from 0 to 63, with the next network starting at 64, okay? Go back to the VLSM video if you're not sure how we got there. Right, the next one was 10.0/25. Obviously, we've already used the 10.0 subnet, right? So we can't use it again. 0 to 63 is officially taken by answer B, which means we cannot use 0 to 63 in any of our other answers. It cannot be an option, right? So again, .32, again, cannot be an option because we've used 0 to 63. So .32 cannot be one of our networks. Right, 64/27, right? 27 means 3 bits in the last octet, right? So 255.255.255, that's 24 bits, plus 3 will get you to 27. 3 bits in the top order, your last network bit will be 32. Which is what we use for our 30 hosts per subnet. So 64/27 works, all right? And because we need 2 networks with 30 hosts each, you'd have to add 32 to that, which will take you to 96, right? So 96/27 should be another answer, right? That would be another correct answer, and that would take us up to 127 if you do your range calculations. Right, which means 0 to 127 now reserved, they're used, you cannot use them. So the next usable address will start at 128. All right, so 128/27, we only need 6 hosts for the last 2 networks that we're calculating. 27 gives you 30, that's too many. We can drill that down to a fewer number of hosts. All right. /28 would actually give us 16 hosts, or 14 once you leave out the first and last. Also too many for our purposes, right? 128/29, right, will mean that our last network bit was 8, right? And that would accommodate our 6 hosts per subnet. 0 to 7, right? You wouldn't use 0, you wouldn't use 7. So it would be 1 to 6, right? And that accommodates our 6 hosts per network, right? Our last network bit in that case for 29 bits will be 2 to the power of 3 or 8, right? So you'd add 8 to that to get 136, right? 136/29 would be the last network. Okay, now if you found that a little confusing without me putting the actual calculation up, let me know, give me some feedback, and I'll post a more comprehensive solution. Thanks for watching.